Welcome back. To get started with this lesson, go ahead and open up your command line or terminal and type the command ipconfig or ifconfig, depending on if you're on a Windows machine or a Mac OS machine. Look below the IP address this time for something called the subnet mask, and mine looks like this. It's got 3255.0. Now, as a quick note, if you're on a Mac, you'll actually see the net mask in hexadecimal format, which will require a conversion to decimal, which can easily be done with online calculators. Simply search for hexadecimal to decimal. So what is a subnet mask and what does it do? Well, a subnet mask, also known as a network mask, is used for subnetting, which is what divides a network into smaller networks. And those different networks need to know which IP addresses they can use and hand out to devices in their subnetworks. So this is how we can say, hey, this part of the network gets these IP addresses, and then this other part over here of the network gets these other IP addresses. Now the network mask looks a little bit like an IPv4 address since it also has 4 octets. And with this subnet mask, you get the first 3 octets by turning all of the bits into ones. That's how you get 255, because if we add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, we get 255. Whereas for the last octet, which is a 0, you get that by turning all of its bits into zeros. Now, oftentimes, you will see this specific subnet mask represented with a /24 or a different number. So if you've ever seen an IP address that looks like 172.16.1.0/24, that /24 specifically represents the subnet mask of 255.255.255.0. And you get this notation by adding up all of the ones in a mask. So in our example, the first 3 octets are all ones, as we've talked about, and then the 4th octet is full of zeros. So the first 3 octets equals to 8 ones per octet. So you do 8 times 3, which equals to 24. You can even have a /20, /21, /22, all the way to a /32, depending on how many continuous ones you have. And that's important to know because it changes the number of IP addresses that can be used by the partition of the network. Technically speaking, you could even have subnets starting from /8 all the way to /32. Now with a /24 subnet, you can have up to 254 usable hosts in that subnet. With a /25 though, you can have 126 usable hosts. And then with a /20 subnet, you can have up to 4,094 usable hosts. So /24 is a common and popular subnet because it makes things easy. A network with a /24 subnet means that the first 3 octets will always remain the same, so only the 4th octet changes per host in that network. So if we go back to our engineering subnetwork, we can see this in action because that subnetwork could very well be a /24. The router interface IP is 192.168.1.1. The host number 1 is .2 instead, then host number 2 is .3, host number 3, .4, etc. That subnetwork starts with 192.168.1 and then the last octet, which is what's unique to each host. Because it offers 254 usable hosts, the range of IPs can go from 192.168.1.1 all the way to .254. So choosing this subnet can leave room for growth in the future, and that's why, again, it's one of the popular ones. Now, on the other hand, when we say that we have a /25, we can have 126 usable hosts. We say that because /25 breaks it up into 2 different subnets. You have network number 0.0 and network number 0.128. The network number of 0.0 has an IP range of 0.1 to 0.126, and then it's got a broadcast address of 0.127. Ignore the meaning of broadcast for now. We will explain that in another lesson, but do note that the broadcast in this table does eat up 2 different hosts, which is why /25 only offers 126 hosts instead of 128. Because then if you look at the network number 0.128, you would have a range of 0.129 to 0.254. But again, there's a 0.255 that's reserved for broadcast. And so that's why you only have 126 hosts. So with /25, we could have a network that has IPs all the way from 192.168.1.1 as an example, all the way to .126. And then you could have a separate network that has 192.168.1.129 all the way to .254. But how do I know this? How do I know a subnet's IP range and how many usable hosts it can have? Well, let's go ahead and complete this lesson. And in the next lesson, we're going to talk about network IDs and host IDs, which can be used to determine this information. So I'll see you there.